Chapter 11.4, Angle, Similarity of Triangles. Okay, so this chapter, we have several theorems, several similarity theorems that we got to go over. There's three, and they're very simple. The first one is the angle, triangle, similarity theorem. It states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. The theorems that we're going to look at today are very similar to the ones that we already saw, but those that we saw earlier in the year were called triangle congruency theorem. Those that we saw earlier in the year are for when two triangles are congruent, when they're exactly the same. Okay, but these theorems today are for when two triangles are similar, which means that their angles are going to be the same, but their shape could be bigger or smaller, and their sides are going to be proportional. So this theorem is saying that if two angles are congruent in the two triangles, then the two triangles, we could determine that they got to be similar because of that, because of the AA triangle similarity theorem. Okay, we'll look at some examples in 1 second. Let me just say that in Spanish. Okay, así que para empezar este capítulo tenemos este teorema que dice que si dos ángulos de un triángulo son congruentes a dos ángulos de otro triángulo, entonces los dos triángulos son similares. Esto es el teorema de ángulo, similaridad de triángulos. Okay, así que si dos ángulos de un triángulo son congruentes a dos ángulos del otro triángulo, entonces los dos triángulos tienen que ser similar. All right, so let's look at our first example here. It says, find the indicated length if possible. They want us to find the length of BE. Now look what it says here. First, determine whether the two triangles are similar. Okay, let me go over how you can determine that they're similar. They are, but you got to know how to do it because there's questions on the homework about that. All right, so first thing you should look at, or first thing you should notice, is that these two lines are parallel. So just to draw a similar example here, remember that when you got two parallel lines, all right, and let's say that transversal, intersecting both parallel lines, then this angle will always equal this angle. And same thing on the other side. If I have this transversal, this angle is going to equal this angle. That's the alternate interior angle theorem. So in this diagram, this angle equals this angle, and this angle equals this angle. All right, which is what they're mentioning right here by the alternate interior angle theorem. Okay, this angle equals this one, and this one equals this one. We could have also said the vertical angle theorem to get this one, but it wasn't necessary. All right, so that's just establishing that the two triangles are similar. Let me say that in Spanish before I continue the problem. But if you understood that, we're going to use a proportion to solve it in a second. Ok, así que dice que tenemos que encontrar el largo indicado si es posible. Ok, así que lo primero que tenemos que hacer es determinar, porque tenemos que encontrar el largo del lado BE. Lo primero que tenemos que determinar es si los dos triángulos son similares. Ok, así que aquí estas flechas, recuerden que estas flechas quieren decir paralelo. Así que como estas dos líneas son paralelas, eso quiere decir que este ángulo es congruente a este ángulo y este ángulo es congruente a este ángulo por el teorema de ángulos alternos en el interior de un transversal. ¿Ok? Porque recuerden que cuando tienen dos líneas paralelas y hay un transversal intersectando, este ángulo es congruente a este y aquí este sería congruente a este. Así que a la vez que comprobamos que tenemos dos ángulos congruentes en un triángulo a el otro triángulo, ya podemos determinar que los dos triángulos son similares. Y ahora voy a usar una proporción para encontrar el lado que me falta, que es BE. Este lado me están pidiendo el largo de este lado. All right. Once we show that two angles in one triangle are congruent to two angles in the other triangle, then we've proved that they're similar by the AA triangle similarity theorem. Okay, now I'm gonna find the length of this missing side right here. Okay, so they set up a proportion comparing. There's more than one correct way to set it up. You don't have to set it up exactly the way they did, but they're doing BD over BA. BD is to BA as BE is to BC. All right, so when you set it up, 54 over 36 equals, you could put BE or you could put X. I'm going to put X. It means the same thing, whatever makes you happy. All right. Now, I don't like the way that they solve their proportions. All right, I'm going to do it my way. You could do it their way. Let me just get a calculator here. Their way is they're multiplying both sides by 54 to get rid of the denominator. Okay, my way is the way you learned in middle school. Let me just erase all this. On second thought, I'm going to use BE just to keep it the same. All right, my way is to just cross multiply 54 times 54 and 36 times BE. So this will be 36 times BE equals 54 times 54, which equals 2,916. So BE is going to equal 2,916 divided by 36. So BE equals 81. All right. Así que hice una proporción, pero en lugar de hacerlo como ellos lo están haciendo, ellos están multiplicando los dos lados por 54 para eliminar el denominador de los dos lados. Yo creo que es más fácil hacerlo de esta manera. Simplemente multipliqué diagonalmente 54 por 54 para coger 2.916 y 36 por BE, que es el lado que no sé cuánto mide. Y entonces dividí por 36 y mi respuesta es 81. All right, next example. All right, this one I just put the answers to make it easier to analyze, all right? Again, you got to know this stuff for your homework, right? Similar question, we got to find how long is RT. RT is all of this. Okay, tenemos que encontrar la medida de RT. So first of all, it says check whether the two triangles are similar. That's important because on your homework, you're going to have some where the two triangles, you cannot determine that they're similar, so therefore you can't get the answer. Okay? Es importante saber cómo determinar si los dos triángulos son similares, porque en la tarea hay algunas preguntas donde los triángulos no son similares y no se puede coger la respuesta. All right, so let me see, it is given in the diagram that angle RSV is congruent to angle. All right, I would look at it this way. Let me draw two triangles here. Hold on, let me do that better. All right, so RSV. And let me draw the bigger triangle here. This may help some of you to see it better, to see what I'm going to say better. All right. So first of all, look at these lines right here. That's telling you that angle S is congruent to angle T. Okay? Ángulo S es congruente a ángulo T. Now the other thing is, look, both triangles, the little triangle and the bigger triangle, they both share angle R. They both have angle R in common. So of course, angle R has to be congruent to itself. So that's what they're writing here. Angle R is congruent to angle R by the reflexive property of congruence. So that's it. Now we have our two angles in one triangle that are congruent to two corresponding angles in the other triangle. And once we show that, then the two triangles are congruent by the angle triangle similarity theorem. Or I'm sorry, I said congruent, my bad. I meant to say similar. the two triangles are similar by the angle-angle-triangle similarity theorem. Okay, now from there, they're just going to set up a proportion, which you could see for yourself, in order to solve for the side that's missing. They're asking us to find RT. So like if you look up here, it's a little easier to see, I think. Oh, you know what? I forgot to write the numbers. Let me write that side RS is 10, SV is 8, and this side is 12. Okay, now look, you got to know how to write the length of RT. We went over this in a recent lesson, but just to remind you, in case you weren't paying attention, RS is 10, and we don't know what ST is. So how do you write the length of RT? The way you would write it is you put a variable for ST. I'm going to put the letter X. So that means that the length of RT, you would write it as 10 plus X. Wait, is it necessary on this problem? Let me think here. Actually, I'm sorry. What I did is right, but for this problem, that's not necessary. So if I get a chance, I'll erase that. If not, it'll stay in the video. So what I wrote is right, but it's not necessary for this problem, okay? So they're going to set up a proportion comparing 10 is to RT. I'm going to write it my way. I'm going to go from this triangle to this triangle. So 10 over RT equals 8 over 12. I mean, to me, that's simpler. The smaller to the bigger one. So 10 is to the one that I'm looking for, RT, as 8 is to 12. Now down here, I multiply diagonally. I'm going to get 120 equals 8 times RT. So RT is going to equal 120 divided by 8. So RT is going to equal 15. All right. Let me just say that in Spanish. Así que lo primero que tenemos que hacer es comprobar que los dos triángulos son similares. Nos dicen al principio que este ángulo, o nos dice en el diagrama que ángulo S es congruente a ángulo T. Y si se fijan, los dos triángulos tienen en común ángulo R. Así que claro que ángulo R tiene que ser congruente a él mismo por la propiedad reflexiva. Así que ya con eso tenemos los dos ángulos en un triángulo que son congruentes a dos ángulos en el otro triángulo. Así que los dos triángulos son similares por el teorema de por el teorema de ángulo similaridad de triángulos. No sé si lo estoy traduciendo bien, pero bueno, más o menos. A la vez que sabemos que son similares, hacemos esta proporción para resolver para el lado que falta, que es RT. Yo lo hice de mi manera aquí. Empecé a hacer otra cosa, pero me di cuenta que no era necesario, así que lo borré. All right, let's go to the next one. All right, look, I'm putting these with the answers so that we could just analyze them and you could and do it a little quicker. All right, remember that if when you're doing your homework assignment, you need help or you're stuck on a question, there's a good chance that it's included in my video. So you could just go to the video and look for it, okay? All right, so this one, remember that when you add up all the angles, all the interior angles of a triangle, it has to give you 180. All right, so when I subtract these two numbers from 180, I'm going to get, it says it right here, that the measure of angle C is going to be 67. Okay, that allows me to see that, hey, that this angle is congruent to this one, and this angle is congruent to this one. So therefore, by the AA triangle similarity theorem, the two triangles are similar. Okay, on this side, okay, first of all, notice these lines. These lines are telling you that the two triangles are isosceles triangles. Okay, now it says that this angle right here is 16. So that means that in an isosceles triangle, angle B has to equal angle C. So these two got to be the same. So I could do something like, hey, 2x plus 16 has to equal 180. The x is like this one and this one because I don't know how much those angles measure. So 2x plus 16 has to equal 180. That means that 2x equals, when I subtract 16, that'll give me 164. And then 164 divided by 2, x equals 82. So each one of these angles is 82 and 82. Okay, now if you look at the triangle on the right, this one's 78. It's an isosceles triangle, so this one also has to be 78. So you can see there that we're not going to have two angles that are congruent to two other angles in the other triangle. So therefore, the two triangles are not similar. All right. Let me just try to say all that in Spanish as quickly as I can. Okay, en el número 3, recuerden que la suma de los ángulos interiores de un triángulo siempre te tiene que dar 180. Si le restamos a 180 estos dos números, 65 y 48, eso nos da 67. Así que ángulo C mide 67 y ahora podemos comprobar que ángulo C es congruente a ángulo F en este triángulo y ángulo A ángulo D. Así que como tenemos dos ángulos congruentes a dos ángulos, los dos triángulos son similares por este teorema. En el otro ejemplo, en el número 4, lo primero que tenemos que darse cuenta es que esta línea quiere decir que estos lados son congruentes. Tenemos dos triángulos isósceles. ¿Okay? Cuando son isósceles, estos dos ángulos tienen que ser congruentes y estos dos ángulos tienen que ser congruentes. La información que nos dieron simplemente era que este ángulo mide 16. Así que si yo no sé cuánto mide este ángulo, pero tiene que ser igual que este ángulo, puedo hacer 2x más 16 igual a 180. Y cuando encuentro el resultado, creo que era 84, ya se me olvidó. 164, no, 82. Ok, cada ángulo mide, cuando resuelvo para x, cada ángulo medía 82 y 82. Y como este es 78, este también tiene que ser 78. Y ya con eso puedo ver que los ángulos no son congruentes. No hay manera de coger dos ángulos en este triángulo congruente a dos ángulos en este triángulo. Así que no pueden ser similar. All right, same type of question. Let's look at these. The answers are there. So with the given information, they're giving us in the diagram this line right here. That means this angle is congruent to this angle. We don't know anything about this angle, and we don't know for sure if these lines are parallel, so don't assume that they are parallel. However, we do know that these are vertical angles right here. This angle is a vertical angle with this one. So therefore, I got my two angles. So the two triangles are similar by the AA triangle similarity theorem. Okay, and on this one, this is like probably one of the trickier ones. I think it comes out on the homework, I'm not positive. All right, but if you look at this one, okay, first of all, they tell you that this is a right angle and this is a right angle. So right there, I got this angle is congruent to this angle because they're both 90 degrees. Now also, because these two lines are parallel, that means that this angle right here has to be congruent to this angle right here. They're explaining this down here by the alternate interior angle theorem. So there, I got my two angles in each. Two angles in one triangle that are congruent to two angles in the other triangle. So therefore, by the AA triangle similarity theorem, the two triangles are similar. En español, en el número 5, nos dieron que este ángulo es congruente a este ángulo. Ok, y también, no podemos decir que este lado es paralelo a este lado. No lo sabemos, no estamos seguros de eso porque no nos dan información sobre eso, así que no lo podemos asumir eso. Pero sí sabemos que aquí tenemos ángulos verticales, así que este ángulo aquí es congruente a este ángulo aquí, y ya con eso tengo mis dos ángulos en un triángulo que son congruentes a dos ángulos en el otro triángulo, así que tiene que ser similar por este teorema. ¿Ok? Y aquí en el diagrama nos están diciendo que este ángulo es un ángulo recto y este también. Así que esos dos son congruentes. Además de eso, estas dos líneas son paralelos, así que eso quiere decir que este ángulo es congruente a este ángulo. por el teorema de ángulos alternos en el interior de un transversal. ¿Ok? Ok, así que ahí tengo mis dos ángulos que son congruentes a dos ángulos en el otro triángulo, así que son similar. Estaba pensando si es mejor decir ángulos alternos en el interior de líneas paralelos, no sé. Tengo que buscar, siempre se me olvida cómo traducir eso correctamente. All right, next example. All right, again, these are on your homework. And actually, I need to pause the video because I have a class starting. I'm doing this video at school, so 1 second here. All right, so let's look at this example number 6. A builder was given a design plan for a triangular roof as shown. Explain how he knows that triangle AED is similar to triangle ACB, and then find AB. All right, I already did an example like this. Okay, basically, once again, wait. If we look at the little triangle compared to the big triangle, I tried to draw it better, but it came out pretty much the same. All right, they both share this angle, angle A. They both have angle A in common, and when you have parallel lines, that means that this angle is congruent to this one, and also this one over here is congruent to this one. So really, all three angles are congruent, all right? But you could use any of those to justify that the two triangles are similar. Okay, and once you do that, all right, so we have 6 and 9 and 15, and this is the side we're looking for. All right, side AB. All right, so I would set up my proportion. I mean, there's more than one way to set it up correctly, but I would do 6 is to AB as 9 is to 15. This is AB right here. All right, so I would multiply 6 times 15, which will give you 90, and 9 times AB. So AB equals 90 divided by 9, so AB equals 10. All right, let's look at number 7. Okay, number 7 is a little more tricky. I mean, it's easy, but it's a little. I can see how you might get, some of you might get confused. So let's look at number 7. Okay, what I want you to see in number 7 is this. I'm going to draw 2 triangles so you could see what I'm trying to get you to see. I don't know why I can't draw all of a sudden. Let me try that one more time. Probably because I'm tired. All right. All right. That part is already there. Now let me show you the part that's not there that I want you to see. What I want you to see is this. All right, what I just drew, this triangle is this triangle right here, except like if I were to push it down to the left. All right, because that's how they correspond. That's how they're in the correct. That's how they're in the same order, basically, the same orientation. All right, just one moment. Okay, because this angle right here is congruent to this angle, and also you see how this is a 90-degree angle and this is a straight line? That means this is also a 90-degree angle. So I'm going to add that here right as well. So if you look at it the way I drew it, right? This angle is congruent to this one, and this 90-degree angle is congruent to this 90-degree angle, and the two triangles are similar. And we could see like which side corresponds to what side, okay? It's a little easier. All right. So before I set up the proportion, let me just say that in Spanish real quick. Lo dibujé los dos triángulos de esta manera para que lo puedan ver lo que quiero que vean. Que es que este triángulo lo dibujé igual, pero este triángulo lo puse, imagínense si lo empujo a la izquierda ¿ok? Eso lo dibujé de esta manera y ahora se puede ver más fácil cuál lado corresponde con cuál lado, cuál ángulo corresponde a cuál ángulo. Ángulo T corresponde a ángulo P y los dos son congruentes. Y también aquí, como esta línea es perpendicular, la línea PS es perpendicular a la línea TR o el segmento TR. Por eso es que este ángulo es 90 grados y este ángulo también es 90 grados, que lo dibujé aquí. Así que ángulo S es congruente a ángulo S en este triángulo. Ok, y ahora podemos ver más claramente cuál lado corresponde a cuál lado y hacer la proporción correctamente para encontrar PQ. Ok, next step is PQ. All right, so in this one, what I got to do is this. PQ, we don't know what PQ is, so I'm going to put an X. All right, aquí no se sabe cuánto es PQ, así que puse una X. Okay, why did I do that? Because, let me write the numbers that are missing so you could see. All right, so RS is 12. And QS, sorry, I'm looking at this. Oh, QS is 9. Okay, and look, this is the key ingredient. What is the length of PS? What is the length of PS? If you look right here, PS is this line. The length, you would write it as x plus 9 or 9 plus x, whichever way you want. I'm going to write it as x plus 9. Okay, again, the length of PS, that's the key ingredient to this problem. You got to know that to write PS, you got to write x plus 9. Actually, now that I think about it, you don't have to do it that way. You could let's just put an x. I'll show you another way you could do it. Now let me leave it. Sorry, x plus 9. X plus 9 it is. All right, sorry. There is another way, but I don't want to confuse it. That may make it more confusing, so let me just leave it like that. Okay, so now I'm going to set up my proportion. Again, there's more than one correct way to set up the proportion. I'm going to do it like this. I'm going to compare this side, the 9 to the 12 equals the 15 to the x plus 9. So 9 over 12 equals 15 over x plus 9. Now I'm going to cross multiply. So 15 times 12, if you give me a moment to do that on a calculator, 15 times 12. All right, 15 times 12 is 180. And 9 times x plus 9. When I do the distributive property, it's going to give me 9x plus 81. Subtract 81 from both sides. That's going to give you 99 equals 9x. So x is going to equal 99 divided by 9, so x equals 11. So that's my answer for this one. PQ is 11. Okay, and let me tell you another way, a quick way. The other way that I was thinking about explaining it to you was just put an x here, and when you do all that multiplication, you would have gotten, or if my calculations are correct, you would have gotten 19. All right, 19, and then you would have subtracted, not 19, I'm sorry, 20. You would have gotten 20. All right, and when you get that 20, you would just subtract this 9 to find the part that's missing. So again, I could have also just left this as PS or put an X there. When you cross multiply and divide, you're going to get 20 for this side for PS. But since they're only asking for segment PQ, you would then subtract 20 minus 9, and that would give you PQ, which is 11. All right? Just one moment. Sorry, I'm a little distracted because I'm like managing a online class while my video lesson is playing and also recording this video. So, okay, let me just explain that real quick in Spanish. Okay, así que en español hice una proporción comparando este lado, el 9 al 12 es igual al 15 a x más 9. Esa es la parte importante, pero también hay otra manera que lo pueden hacer. Okay, yo lo hice de esta manera donde para PS escribí x más 9 y lo puse en la proporción. Cuando multipliqué diagonalmente y resolví para X, me dio la respuesta que X es igual a 11. X era el segmento PQ. Pero otra manera que también se puede hacer, así que si están pensando, si lo ven más claramente de esta manera, háganlo de esta manera. Es, en lugar de escribir aquí X más 9, simplemente escribir X para encontrar la medida de este lado completo, PS. ¿Ok? Si lo hago de esa manera, cuando hago mi proporción y multiplico y divido y resuelvo para X, me va a dar 20 para el lado PS y entonces lo que me queda, lo que me falta por hacer es restar 20 menos 9 para coger el segmento que me están pidiendo que es PQ. 20 menos 9 me daría 11. Alright guys, let me pause the video one more time here, just one moment. All right, guys. Okay, now there's two other triangle similarity theorems that we got to go over. The first one is side triangle similarity theorem. If the three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. And the other one is side triangle similarity theorem. If two sides of one triangle are proportional to the corresponding sides of another triangle and their included angles are congruent, then the triangles are similar. We'll look at some examples like that in one moment. It's basically the same thing that we saw earlier in the year with triangle congruence theorem, except now with similarity theorems. Así que aquí tenemos los otros dos teoremas que tenemos que mirar hoy. El primero es lado, triángulo, similaridad, teorema, que dice que si tres lados de un triángulo son proporcional a los lados correspondientes de otro triángulo, entonces los triángulos son similares. Y aquí lado, ángulo, lado, si dos lados de un triángulo son proporcional a los lados correspondientes de otro triángulo y el ángulo y los ángulos incluidos en el medio de esos dos lados también son congruentes, entonces los triángulos son similares. All right, so here's our first example, and I'm gonna draw you. I'm gonna draw it for you so that in a different way so that you could see what you need to see because it's a little tricky this one to see what they're saying. All right, so the first triangle I'm drawing it the same way. You got triangle MNP. This side is 4 and this side is 8. Okay, now this triangle down here that's upside down, I'm gonna put it right side up. All right, so you could see how it compares. All right, M, the R is up here and the Q is down here. Okay, so MR measures 6. Okay, and what I want you to see is the length of MQ. MQ, this portion is 8. From M to P is 8, and from P to Q is 4. So in total, this has to be 12. All right, I hope you realize that. Because the way they have it is very tricky. You need to look at it. Give me 1 second. Okay, sorry about that. Okay, so the way they have it drawn, it's very tricky to see. It could be tricky to see it. And even me, when I first looked at it, I compared the wrong sides. All right, so you got to be careful and make sure you're looking at it correctly. Once you're looking at it correctly, you can check to see if the sides are proportional. This side goes with this side, so I would write 4 over 6. What they're doing here is they're simplifying it and checking what is the ratio of one side to the other. So when I simplify that fraction, I get 2 over 3. If these triangles are similar, when I compare this side to this side, it's got to give me the same fraction, the same ratio. So 8 over 12, when I divide the top and the bottom by 4, I also get 2 over 3. That means that, yes, they're both similar. Okay? Because we have two sides that are proportional and the included side, the side in between those, I'm sorry, and the included angle. Let me try saying that again. We have two sides that are proportional and the included angle on this triangle is congruent to the included angle in the other triangle. All right, so by the side angle side triangle similarity theorem, the two triangles are similar. Let me try saying that in Spanish. Okay, en español, esto es un poco difícil ver claramente, por eso lo dibujé aquí. El triángulo que está boca abajo lo dibujé de esta manera para que puedan ver cuál lado corresponde a cuál lado y cuál ángulo a cuál ángulo, porque la manera que lo tienen dibujado es un poco difícil ver. Pero ok, este ángulo es congruente a este ángulo. Este lado corresponde a este lado corresponde a este lado, y lo que tengo que hacer es chequear si los lados son proporcional. Si son proporcional, eso quiere decir que cuando comparo este lado a este lado y simplifico el radio, simplifico esta fracción, me tiene que dar el mismo radio, 2 sobre 3. El mismo radio que cuando lo hago con el otro lado. 8 sobre 12 cuando lo simplifico también me da 2 sobre 3. Así que como estos dos lados son proporcionales y el ángulo que está en el medio es congruente a este ángulo que está en el medio de estos dos lados, los triángulos son similar por lado, ángulo, lado. I had a tough time explaining that one in Spanish. Maybe in English too. All right. All right, so this one I just put it with the answers so you could analyze it with the answers. This one's going to be by the side triangle similarity theorem. Okay, there's no information about any angles. But basically, when you compare, you are given 3 pairs of corresponding side lengths and 0 congruent corresponding angles. So try using the side triangle similarity theorem. When they compared the corresponding sides, they got 3 over 2 for all of them. So the ratio is the same when you compare all the corresponding sides. So therefore, the sides are proportional. That means the two triangles are similar by the SSS triangle similarity theorem. Ok, en este ejemplo nos dieron 3 pares de lados correspondientes y no nos dieron ningún ángulos correspondiente. No tenemos ninguna información de ninguno de los ángulos. Así que dice que debemos tratar usando el teorema de lado de similaridad en triángulos. Okay, así que cuando compararon los lados correspondientes y simplificaron los radios, nos dieron el mismo radio para cada uno de ellos. Así que eso quiere decir que los lados son proporcional y los triángulos son similar por lado. All right, so you're going to have questions on your homework like this where you got to determine. First, I'm telling you right now, there's some of these, they're not similar. So you got to first make sure you determine, are they similar or not? Or actually, I'm sorry, that is the question. I'm getting confused today, guys. I haven't gotten much sleep, so I'm getting confused on a lot of these questions. So if possible, determine whether the given triangles are similar. All right, so that's all we got to do. Are the two triangles similar? It could be either by AA, angle, or by side, or by side, angle, side. All right? So if we look, in this one, they're giving us this angle is congruent to this angle. Okay? Side, angle, side, it would have to be the side in the middle. Side, angle, side, it would have to be the angle in the middle, and they don't give us this side. And we don't have any information to do side, so I would say no, it's not possible. I'll check in a second if I'm right or wrong. But on that one, they don't, in order for it to be side, angle, side, we'd need this side, and they don't give us this side to compare. All right? They don't give us two angles to be able to check if it's AA, similarity theorem. And we don't have enough information to do 3 sides. Okay, now let's look at this one down here. Okay, now there's a big difference. This one down here, they tell us that this is a 90-degree angle, which allows us to use the Pythagorean theorem to find the side that's missing, all right? So remember, a squared plus b squared equals c squared. All right, let me make this one b. So if I do 8 squared plus b squared equals c squared, all right, that'll be 64 plus b squared equals 100. So b squared is going to equal 100 minus 64. So b squared is going to equal 36. And the square root of 36 is 6, okay? So b equals 6. So this side measures 6. Okay, if I use the Pythagorean theorem on this one, this is a Pythagorean triple, so is this one, but I didn't have this one memorized. I do have this one memorized. The side that's missing is 4. If you don't know what I'm talking about, just basically whenever the hypotenuse is 5 and one of the legs is 3, the other leg is 4. And whenever the hypotenuse is 5 and one of the legs is 4, the other leg is 3. I believe we go over that later on in this year. Or maybe we did it already, I can't remember. Anyways, now with this one, I can check to see if this is going to be side, side, side or not. All right, so the hypotenuse, I compare it to the hypotenuse and I get 2 over 1. This side, I'm going to compare it to this side. I did that wrong, I'm sorry. This side goes with this side, 8 over 4. So I'm also going to get 2 over 1. And this side goes with this side, 6 over 3. So I also get 2 over 1. All right, so the top, number 10 was no, it's not possible. Number 11 is yes, by the side, side, side triangle similarity theorem. Ok, así que de arriba no es posible determinar si son similar porque no pude hacer ángulo a ángulo porque solamente me dieron un ángulo, información para un ángulo. No pude hacer lado, ángulo, lado, porque no, para hacer lado, ángulo, lado, tiene que ser un lado, el ángulo en el medio y el otro lado. Y no me dieron información sobre el otro lado. Y no puede ser lado, 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 porque no me dieron los 3 lados. El de abajo es un poquito diferente, porque nos están diciendo que este ángulo es un ángulo recto. ¿Ok? Así que eso me deja usar el teorema Pythagorean para encontrar el lado que falta. A a la 2 más B a la 2 igual a C a la 2. Cuando usé esa fórmula, este lado es 6 y este lado es 4. ¿Ok? Y ahora sí puedo comparar los lados correspondientes para ver si son proporcional, que es lo que dice aquí, y si son proporcional porque todos me dan un radio de 2 sobre 1. También se puede poner al revés y te da 1 sobre 2 y eso también está correcto. All right. All right. I'm just leaving the answers in case anybody needs to look at them. All right. I did it the way I did it. They did it the opposite. They did 1 over 2, but that's the same thing. All right. You could do it either way and it works. Just one moment. Okay. Sorry about that. Once again, I'm checking on a class and letting people into a class where another video is playing and recording this video and trying to keep track of both. Okay, so here's some more examples. Okay, for the sake of time, all right, I'm not going to do these examples. What I am going to do is I'm going to put up the answers so that if you need help on the homework, you can look at them to guide you. I say for the sake of time because otherwise if I go over every one of these, the video is going to be like a good 20 or 25 minutes longer. And that's really asking a lot of you guys to pay attention for that long, okay? So for these 4 problems, these are the answers. In case, I'm telling you, there's a good chance you're going to have similar questions on the homework. Okay, estos problemas no lo voy a explicar porque si explico cada uno de estos problemas, este video va a ser 20 o 25 minutos más largo. Okay, pero si estoy poniendo la respuesta porque van a haber problemas similares en la tarea y pueden usar este video para ayudarlo en lo que hacen las tareas. Si no se han dado cuenta, en todos mis videos trato de poner ejemplos de lo que está en la tarea y lo pueden usar para hacer los problemas en la tarea. Muchas veces es bien similar y a veces exactamente la misma cosa. All right, and here's 4 more questions, and I'm going to put up those answers as well. All they're doing is checking for all of them, whether you could do side, side, side similarity theorem, or angle, angle similarity theorem, or side, angle, side similarity theorem. There's only 3. And if you can't do any of them, then it's not possible to determine whether they are similar. Okay? En todos estos problemas están chequeando si se puede usar una de las 3 teoremas que aprendimos hoy. El primero era ángulo, ángulo. El segundo era lado, lado, lado. Y el tercero era lado, ángulo, lado. Si no se puede usar ninguno de esos 3, entonces no es posible determinar si son similar. All right, guys. If you have any questions, you can message me on the Remind app. But that's it for this lesson. The assignment is in your student portal, and like always, it's due by 6 a.m. the next day that you have my class. Hope you guys have a great rest of your day, and I'll see you guys next class.